This is Open Campus with Miss Black. We are in Module 11 now, and we are going to actually learn how to solve a new equation today. As you've seen as we've been going through the modules, we solve equations and then we graph, draw pictures. We're back to a new equation. And if you've never had like an advanced math class, if you're only coming out of the developmentals at BIPSI, the 097, 098, 099, you have never seen this kind of equation before. Now don't get scared, it's not hard. It's just a new equation. The new equation is called exponential. Now think about that, that's a fancy word. What do you think exponential means? Very good, it has something to do with an exponent. So let's go to our class notes and look at this. Okay, if you look at your class notes, the definition says an exponential equation is an equation in which the variable is in the exponent spot. So everybody look at my examples. 2 to the x equals 8. That's an equation, it has an equal sign. 1/3 to the x equals 9. That's an equation, it has an equal sign. What's different, if you look, is the letter x is in the exponent spot. You've never seen that before. If you go back to Module 1, to all those equations we learned how to solve, in Modules 1, 2, 3, 4, 5, 6, and 7, none of them had the x in the exponent spot. We've seen linear equations where the exponent's been a 1. We've seen quadratic equations where the exponent's been a 2. We've seen polynomial equations where the exponent's been a 3 or a 4. And we've also seen rational exponent equations where the exponent's been a fraction, 1/3, a half, 3/2, 2/3. But this is totally new. What I want you to notice is the exponent's always connected to the base. And the definition says the base has to be a positive number. So if you look, the first base is 2. That's positive. The second base is 1/3. That's positive. What you cannot have as the base is the number 1. And the reason why is, think about this. If you had the number 1 and you put an exponent on it, will it change? Well, 1 to the first is 1. 1 squared is 1. 1 cubed is 1. So that's why the number 1 is excluded from this definition. The base has got to be a positive number, but it cannot be a 1. Okay, what we want to do is solve an exponential equation. So if you look at your notes, here's a simple one. 2 to the x equals 2 to the 5th. Now, I bet all of you can look at that and solve it without doing any work at all. Because if you look closely, what do you know about equations? The equal sign means the left side has got to be equal to the right side. They got to balance. Well, what do you already notice that is balanced in these equations? That's right, the base. The base on the left is 2. The base on the right is 2. Therefore, if the bases are already equal or balanced, the exponents have to be equal or balanced. So everybody look closely. You know the exponent on the right, it's 5. What's got to be the exponent on the left? Very good, it's 5 also. 2 to the 5th would equal 2 to the 5th. So we know by looking at that equation, the solution is 5. So now you've come up with the rule. The way you solve an exponential equation is you have to have the bases be the same. If the bases are equal, then the exponents are equal. So if you look, we have 4 exponential equations we want to solve today. Again, to solve them, you must make sure the bases are the same. So let's go to the whiteboard. Okay, guys and gals, here's my first exponential equation. 5 to the 3x minus 6 equals 125. The first thing I want to make a big stink about is this does not mean distributing. If I wrote this on the board, 5 squared, would you do 5 times 2? No, you would do 5 2 times. So we know an exponent doesn't mean distribute. So if I make this exponent a variable, that does not mean to distribute also. Well, you can't do the base 5 2x times. So the first thing I want you to notice is there's nothing you can do. The exponent's 3x minus 6. We're stuck with it. It's connected to base 5. Now, can we do anything with base 5? No. 5 is a prime number. It's in lowest terms. So we're stuck with this whole left side. But if we go to the right side, can we do anything with 125? Sure we can. We're going to go back to 3rd grade, and we're going to use a concept of a factor tree. Remember, every number can break down into primes. So can you think of two numbers that multiply to 125? 5 times 25 is what I come up with. 5 is prime. Is 25 prime? No, it's 5 times 5. So we learned in 3rd grade we could rewrite 125 to be 5 times 5 times 5. But there's a better way to write that. 125 is really 5 3 times, which is 5 cubed. What can I do with that piece of information? If I know 125 really is equivalent to 5 cubed, what can I do with that? That's right. I can come back up to this equation now and do a substitution. I could say cross out the 125. It equals 5 cubed. Well, look what you've done. You've got the bases to be balanced. And if the bases are equal, then the exponents have to be equal. Well, the exponent on the left is 3x minus 6, and it has to equal the exponent on the right, which is 3. Look what you've done. You've made a simple linear equation from Algebra 1 that you could solve. So we're going to solve it. We're going to add 6. 3x equals 9. We're going to divide by 3, and x equals 3. See how easy that was? So now you have the procedure to solve an exponential equation. You get the bases to be the same, and then you set the exponents equal to each other. Now let's do a mental check. Let's take 3, substitute in the original. 3 times 3 is 9. 9 minus 6 is 3. If you have 5 with an exponent of 3, would it be 125? It sure would. See how simple that was? All right, let's try another one. All right, so our second exponential is 2 to the 2x minus 1 equals 32. Why is it exponential? Because our x is in the exponent spot. Right now, what's our base on the left? It's a 2. Can we do anything with 2? No, 2 is prime. So we're stuck with the left side. What about the right side? What's our base? It's 32. Is 32 prime? No. So let's go do our factor tree. So the first thing I can think of for 32 is 8 times 4. Doesn't matter what you decide. If you use 16 times 2, we're going to be okay. 8 is 4 times 2. 4 is not prime. 4 is 2 times 2. That 2 is prime. 4 is not prime. It's 2 times 2. So back in 3rd grade, we learned 32 is 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. A better way of writing that would be writing 32 would be really 2 to the 5th power. Now, what can I do with that fact? Very good. I could do a simple substitution. I'm going to replace 32 in the original equation with what it equals. 2 to the 5th power. Now, what happened? We got the bases to be equal. If the bases are equal, then the exponents are equal. So let's take our exponent on the left, 2x minus 1. We'll set it equal to our exponent on the right. So what's happening is the bases are kind of canceling out. Now we're going to solve. This is a simple linear equation. We'll add 1. We'll get 2x equals 6. We'll divide by 2, and x is 3. See how easy that was? Now let's do a mental check. Let's take 3. 2 times 3 is 6. 6 minus 1 is 5. If you have 2 with an exponent 5, would it be 32? Sure it would. You just proved it here. So far, so good? Awesome. Let's try one that's a little bit more difficult. All right, let me get my notes so I copy it correctly. The third exponential is 27 to the x plus 3 equals 9 to the x minus 1. All right, why is that an exponential equation? That's right, the variables are in the exponent spot. What do we want to do first? Very good. We want to get the bases to be the same. What's the base on the left? 27. Is 27 prime? No. So let's go over here and do our little arithmetic. 27 is 9 and 3. 9 is not prime. 9 is 3 and 3. So we could rewrite 27 as 3 times 3 times 3, which is 3 cubed. Now, be very careful. We're about to do substitution. Who are we about to replace? We're about to replace 27. What does it equal? 3 cubed. So I'm going to come up here. I'm going to cross out 27. I'm going to put in the spot 3 cubed. Now, what do you think you're going to do with this exponent that's still there? That's right. You're going to bring it down. And it's still going to stay in the exponent spot. But now you have an exponent and an exponent side by side. How do you think they're connected? That's correct. Two exponents side by side are connected by multiplication. You must put parentheses because you got to make sure we're going to take this exponent 3 and multiply it by the exponent that was originally there. All right, look at the right side. We got a 9. Now, if you could factor 9 in your head, that's fine. But for all of us who want to see the work, 9 is 3 times 3. So we can rewrite 9 as 3 squared. So we're going to do our substitution. Goodbye, 9. What's going in its spot is 3 squared. But wait a minute, I still have an exponent, x minus 1. So I bring it down, I leave it in the exponent spot, but then what do I got to put it in? Very good, parentheses, to show multiplication. If you forget the parentheses, your equation's going to be wrong. Now, you got what you wanted. If the bases are equal, now the exponents can be equal. So we're going to take our exponent, 3x plus 3, and we're going to equal it to 2x minus 1. You are back to module 1, a simple linear equation. We're going to use our distributive property, so we get 3x plus 9. And on the right side, when we distribute, we get 2x minus 2. Okay, Ms. Black always moves her variables to the left, so I subtract 2x. So I get x plus 9 equals negative 2. Now I'm going to subtract 9, and I'm going to get x equals negative 11. Okay, every time you solve, what must you do? That's right. You've been working through all these modules. You know you have to check your solution. So when you check, where do you go back? You go back to the original. So I'm going to write the original over here for our check. And we are going to replace each x with a negative 11. So we get 27 negative 11 plus 3 equals 9, negative 11 minus 1. You all know you can only have one number in an exponent spot. So we're going to have to combine these numbers in the exponents. So we're going to leave 27. Negative 11 plus 3 is negative 8. We're going to leave the 9, our base. Negative 11 minus 1 is negative 12. Now we have a huge problem. There's only so much arithmetic you could do in your head. Okay, I understand if I give you an exponent 2 or 3 or even 4, I expect you to be able to work those easy exponents in your head. But there's no way on earth I can ask you to do 27 to the negative 8 in your brain. Not only are the exponents big, they're 8 and 12, they're also negative. So now we got to take a minute and think. What does it mean your answer is going to be if your exponent's negative? Well, let's go back to basics. If I wrote 9 to the first, that would mean 9. If I wrote 9 squared, that would be 9 times 9, which is 81. So we have learned the exponent tells you how many times to multiply the base. Write the base once, write the base twice. Okay, There is no way if you have 9 to the negative 1 to work that. You can't write 9 negative 1 times. So we've already discussed this. We're going to discuss it again in detail. You can't have negative exponents in mathematics. The final answer can never have a negative exponent because it makes no sense. So you learned a trick back in developmental math, in Algebra 2, how to make exponents positive. And the rule is, to make this exponent positive, you would do the reciprocal of the base. What's the base here? 9. If you flip 9, you get its reciprocal, 1/9. And then the exponent becomes a 1. And now we understand what that means. Write 1/9 one time. So what I want you to notice is when exponents are whole numbers and positive, you get positive whole numbers. But with an exponent and negative, you're not going to get a whole number, you're going to get a fraction. Now, think about this. This would mean I'd ask you to do the reciprocal 1/27 and multiply that 8 times. Will everybody understand that? That's going to be huge. So let's talk about what that means. If I have 27 to the negative 8, that's really asking you all to do to take the reciprocal of the 27, which is 1/27, and do it 8 times. Well, we know how to multiply fractions. Top times top, bottom times bottom. Well, the top is easy. If you multiply 1 8 times, 1 times 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 1, you're going to get a 1. But if you multiply 27 8 times, do you agree you're going to get a really big number? And if you take 1 and divide it by a really big number, the value of your answer is going to be very, very small. Think about fractions. Who's bigger, a half or a third? A half is bigger. A third is smaller. And then a fourth gets a little bit smaller. And then a fifth gets a little bit smaller. Because if you're taking a whole item, whether it's a big sheet cake or a piece of paper or a dollar bill, the more you divide it by, the smaller the amount you get. So think about this. This is going to be 1 divided by a really large number. This is going to be very, very small. Now, to get that number, to make sure that we truly have the right answer and this balances, here's where you're going to need a calculator. So, for module 11 and 12, you're going to need a calculator. Now, there are many calculators out for you to use. This is a graphing calculator, okay? These run about $100. You do not need to buy a graphing calculator for college algebra. You do not need to buy a graphing calculator if you have to take finite or trigonometry. The only people that really need graphing calculators are the ones that are going into engineering. So do not go out and waste your money buying a $100 calculator for college algebra. Okay? Now, if you could borrow one of these, that's fine, but you don't need this. What does the same job as a graphing calculator that is a lot cheaper for you guys is this calculator. It's a good old scientific calculator. Now I'm going to bring it close to the camera so you can all see it. If you look, it has all the same buttons as the graphing calculator. This is my favorite. And the reason why this one is my favorite is it reads everything in math like you read a word. You will start at the left and type it like you read a word. So, it's very important you understand, I know you have calculators on your cell phones, but everything to do on a cell phone for this class, you would have to type in backwards, and it's not worth it. It takes more time. So cell phones are unacceptable as calculators in a math class. I know some of you have other calculators that are older versions. If you have an older version calculator, it's not going to work like a newer one, which means, again, you're going to have to type information in backwards, and you're going to get yourself confused. So if you need to buy a calculator for college algebra, this is the best one on the market. You can get it at Walmart, Target, Office Max, Office Depot, Kmart. It's very cheap. It's between $10 and $15. It's a Texas Instrument, a TI 30X Roman numeral 2S. And that's the one I recommend you go buy. A TI 30X2S. It comes in all different colors. I have a blue one. You can go get a pink one, a red one, a green one, a purple one, a black one. But this is the best calculator out there for college algebra and above. So this is what we're going to need now to use because we need to know this value. So now I got to teach you how do you type an exponent in a calculator. Unfortunately, I have no hookup to hook my calculator up for you to see me type in the buttons in this, but I'm going to write it on the board what I would type in. So the first thing when you use your calculator, you want to type in the base. So you would type 27. Now, the calculator is only as smart as you, the operator. You have to tell the calculator the next thing being typed is an exponent. On a brand new, good calculator, the exponent button is called a caret, and it looks like this. That's the caret symbol. It looks like an up arrow. So on my calculator, this TI-30 X2S, there is a button right there that is the caret. Okay? It's right there. So you'll type that. Now, rule of thumb is, every time you type an exponent into a calculator, you should always put an open parentheses to tell the calculator what's coming next is the exponent. Okay? Our exponent we want to type is -8. Now, I don't know if you all know this, but there's 2 negative buttons on every calculator. There's an add, subtract, multiply, divide, so you have a negative for subtract. But there's also a smaller little negative down here, and that's the one we want. We are not subtracting 27 and 8. We're saying the exponent's negative. So we want to use the little negative, type 8, and then close parentheses and hit equals. And I'm going to type that in. So I'm going to type 27 caret, open parentheses, little -8, close parentheses equals. And it's going to spit out an ugly decimal. And you can't play God in college math. You're not allowed to round it. And that's what my calculator spits out. And let me rewrite that because this is a little bit smaller. Now, let's think about this. We just said if we did this in our head, this would be 1 over some huge number, which would be really, really small, which would probably be close to 0. This answer doesn't mean the answer is 3 and something extra. This little -12 is in scientific notation. And what that means is this decimal point really means to move to the left, because you got a negative, 12 places. So if I move this decimal point to the left 12 places, I'm going to run off the screen here. What you would have here is 11 zeros and then the 3. And that would be a really small number close to 0. It is okay that you understand, because we're going to be dealing with exponents. You're not going to always get out nice answers with the calculator. It's okay. But don't be worried. Whatever we got on the left side, we better hope to get on the right side. So now let's type in 9 to the -12. So again, to type that in, you're going to type the base. What's the base? 9. You're going to tell the calculator an exponent's coming. So we're going to hit the caret button. We're always going to put open parentheses after we hit the caret button. What's our exponent? Little -12 equals. So if I type that in, 9 caret, open parentheses, little -12, close parentheses equals, I get out the same decimal. And that proves to me both sides balance. So you are going to need a calculator for this module. All right, we got one more equation in this module to look at. So, our fourth equation is 3x plus 3 equals 1 over 49 x minus 4. All right, why is it exponential? Because the variable's in the exponent spot. The rule is, who do we want the same? We want the bases. The base on the left is 7. Well, 7's prime. We can't do anything with that. Uh-oh, the base on the right is a fraction. Well, you can't do anything with the numerator. 1 is in lowest terms. We all know 49 is 7 times 7, which is 7 squared. So far, so good? Now are the bases the same? No, that's a whole number 7, and that's 1 over 7. Well, there's an easy way to fix that. Don't you agree with me if I flip this fraction? The 7 would come to the numerator, the 1 would go to the denominator, and wouldn't that be 7 over 1, which is 7? So good. That's what we're going to do. To make the bases the same, we're going to do here the reciprocal. The problem is the 1's going to go to the bottom. When we move the 7 to the top, that exponent can't stay positive. It's positive in the denominator, so when you move it to the numerator, it's going to change signs. And then don't forget, we still have that exponent, x minus 4. So we're using some basic arithmetic here. To make a 7 and a 1/7 the same, we're just going to flip the fraction. But when you flip a fraction, the exponent changes signs. Because it was positive, it changes to a negative. Now we all know 7 over 1 is just 7. So if you look now, your bases are equal. They're both 7s. If the bases are equal, then the exponents are equal. So on the left side, the exponent's 3x plus 3. And on the right side, we have negative 2. And we're going to have to multiply it by this x minus 4. Simple linear equation. So we're going to solve. We're going to distribute on the right. We're going to get negative 2x plus 8. We're going to move our variable to the left side. So we're going to add 2x and get 5x plus 3 equals 8. We're going to subtract 3. We're going to get 5x equals 5. We're going to divide by 5 and get x equals 1. To make sure we're right, we're going to do a check. Okay, to do a check, we're going to substitute back to the original. So let's do our check. So we're going to write 7. 3 times 1 is 3, plus 3 is 6. On the right side, we're going to leave our base. And this is going to be 1 minus 4, which is negative 3. Now, this is where you need your calculator. Because it will prove that this is the answer, the right side and left side got a balance. So I'm going to get out my good old $10 scientific calculator. I'm going to type 7 caret, open the parentheses, and type 6. And make sure you close it. And 7 6 times should be a really big number, right, y'all? It is. It's 117,649. So let's hope the left side works out that way. Now, on the left side, the base is a fraction. What you got to know about typing in your calculator is anytime you type a fraction in a calculator, it has to go in parentheses. Okay? This bar means division. So when I type this in, I'm going to open parentheses. I'm going to type 1 divided by 49 and close parentheses. And that shows I put a fraction in. Now I want to put in the exponent, so I'm going to hit my caret. I'm going to open parentheses for my exponent, and my exponent's little negative 3. So I open my parentheses, I put little negative 3, and I close it, and I hit equals. And sure enough, my calculator gives me 117,649. So what we learned today is how to solve a new equation, which wasn't so difficult. It's solving an exponential. All you got to do is get the bases to be the same, then the exponents are equal. The hard part is checking your solution, because if your exponent becomes really, really big, or if your exponent's a negative, the best way to check it is using a calculator. So you all must go and buy a calculator. And like I said, there's a lot of calculators out there. There are Casio calculators. They're okay. But the best calculator out there for your money is this little one right here, TI-30X2S. All right, I'll see you in the next module.